the answer should be what? 0. If I changed the question and didn't say this integral and I said find the area, and what would you tell me the answer was? Positive 0?
No, with the positive answer for adding more.
Yeah, so what would the answer be?
Twelve.
12.5? Yeah? 5 times 2.5 is what? 12.5 divided by 2?
2.5 is equal to
Yeah? Understand? You would add it, right? Ignoring the negativity of it, yes? Good? Understand the difference in the question?
Yes.
Where it could be misleading? Maybe? Okay. Let's try another one here. Now we're gonna get negative x squared plus 3x evaluated from negative 1 to what? To 3. Which one do we plug in first, Danilo? The 3. So we're gonna get negative 3 squared plus 3 times 3 minus negative 1 squared plus 3 times negative 1. On the left, what do we get? Negative 9 plus 9, 0. Minus, what do we get when we plugged in negative 1 earlier? Negative 4, so it's going to become plus 4. We're getting a 4. So looking at this answer, when I draw the graph, what are we going to know? Probably, it could be completely above the x-axis, or it could be predominantly above the x-axis, right? So let's see what happens in this case. We're going from negative 1 to 3. So it seems like we get a triangle here, right? And over here we get another triangle, it's just a smaller one, right? There was more positive space than negative space. Good? So on this one we would get 1 to 2.5 times 5 divided by 2 plus, this one's going to be 1.5, right? Times negative 3 divided by 2. That would give us, I think, 6.25. And then this one would give us negative 2.25. So it ends up being what? 4. Papitas! One more and we're done with this page. Negative x squared plus 3x was the antiderivative, and this time we're going from 0 to 5. Plug in the top number. Negative 5 squared plus 3 times 5 minus negative 0 squared plus 3 times 0. We're going to get 25, negative 25 plus 15, negative 10 minus 0, so we end up with negative 10. This one is probably going to be predominantly where? Below the intersection. Let's check. From 0 to 5. Got this little space right here. And then we got this big space right here. Cool. The area of that little triangle is going to be 2.25. The area of the big rectangle is going to be negative 12.25. So when we combine them, we get negative what? Got it? Easy? What's important here is understanding when you evaluate an integral and being able to interpret your answer and what it means, right? Just because my answer is negative doesn't mean that my graph was completely where? Below the x-axis. It could have been, right? But what it means that it was more space below the x-axis, bounded by the curve and the x-axis than there was above. If it was 0, it means that the space was what? Equal, right? There was the same amount above as there was below. If it was positive, it could be that my graph was entirely above the x-axis, or it could mean that there was just more space up there. Got it? And that's what we're trying to write here. So based on the 5 examples, what inferences can you make about the value of the definite integral and the amount of area bounded by the graph and the integrand and the x-axis? So here, instead of area, let's say the word what? Space. Okay? So 3 statements you're going to write. So if the integral from a to b of the function was less than 0, meaning it was negative, what did that imply? Predominantly where? Below the x-axis, right? So maybe we could say the bounded space, right? Below the x-axis is larger than the space above. Yeah? Or it could also be like Robert said, that it was completely where? Below the x-axis. Good? What if the integral value was positive? And we could say that the bounded space, where? Above the x-axis is larger than the space below. And the last one, which was where the integral was equal to what? To 0. What did that mean? Very good. So the bounded space below and above the x-axis are equal. They're canceling each other out. Kindergarten stuff? Alright, we're almost done. We've got 4 examples that hopefully will take us about 10 minutes. And then you'll have 20 minutes for your assignment. Okay? Which is only 6 problems, so you should be able to finish them if you dedicate your time. So let's look at these guys here. And let's see if they apply to the fundamental theorem of calculus. And if they do, let's actually apply it. Okay? So looking at that first one, what should we check for first? If it's continuous and differentiable, right? So is it continuous? How do I know? Polynomials are always continuous and they're always differential. Alright, so let's jump straight into applying the theorem. So first thing we do is find the antiderivative. What's the antiderivative of 2x? X squared. And the antiderivative of this guy? 1 over 3 x cubed, right? And we're going to evaluate from where to where? -1 to 2. Good? Which one do we plug in first? The 2. So we're going to get 2 squared minus 1/3 times 2 cubed minus the second one. So -1 squared minus 1/3 times negative 1 cubed. Oh no, there's fractions. 2 to the second, what is that? 4 minus 2 to the third? 8 times 1? 8 over 3, right? Okay. Negative 1 to the second, that's 1. But it becomes minus 1, right? And then we have negative 1 to the third, that gives us what? Negative 1 times negative 1/3? Positive 1/3, but then there's a negative there, so it comes back to becoming negative 1/3. Okay? So we could do the 4 minus 1, that gives us what? 3. Negative 8/3 and negative 1/3, that's negative 9/3, which is the same as negative 3. So we get 3 minus 3, so we end up with 0. Oh my God, so that means that the space where? Above the axis is equal to the space below. Okay, now it did say to use your calculator to verify your result, so we're going to use our calculator. Okay? So go ahead and start a new page.
What about
Control N.
the children protected?
Ah.
What
What did I do?
Yeah, very basic question.
Oh, I put yes, I don't want to see.
Is
it plus 1 over 3? No? No, because this is negative times a negative becomes positive times a negative. Good? Alright, so add a calculator page, and what we want to do is enter this integral. And we're going to let it calculate the answer first. So that's going to be under 9, the little template button, and it's going to be down here at the bottom. Okay?
Can we speak to you
Yeah, what's up?
about the idle picture?
Oh, okay. And we're going from negative 1, let me just get them to finish this, okay? Negative 1 to 2 of 2x minus x squared dx. Press enter and see what you get. What does it give you?
Oh, it is up.
Yeah, the negative. Wait, it would be 0. Yeah.
Negative 1.575 to negative 14.
Why does it give me the? It gave me a caution symbol again.
Oh, give it to you too?
Questionable accuracy. Any accurate.
Yeah, because you have like a long ass.
So what do we get?
A caution sign.
Do we get 0?
Warning.
Is that 0?
Yeah.
Is that pretty close to 0?
Very close.
What does that e to the negative 14 mean?
14
That means you move the decimal 14 times to the left, right? So that'll give you a really small number, which is really, really close to what? Is 0. So yes, it is 0.
Wait, what did it give you? It may cause inaccuracies.
Questionable accuracy.
An under approximation? No, this is the exact value. We're not approximating. Look at this next one. You ready?
Accurate.
What's the antiderivative?
Can I get one?
Yeah, you can.
Oh, we gotta check for continuity?
Oh, yeah.
Hey, you guys are good. The other class, number, they did it all. And they got like 5/3. They're like, it's 5/3. And then I'm like, well, what did we forget to check for, right? So what do we gotta check for first? Is it continuous? No, where is it not continuous?
Equals 0.
So we know that it's not continuous at x equals 0, and is that in the interval?
Yeah.
Right. So which is in the closed interval negative 2 to 3. Therefore, the integral from negative 2 to 3 of that function does not what? Does not exist. Type it into your calculator. Let's see what it gives you.
It's gonna shut down.
It's gonna shut down. We're going from negative 2 to 3. 1 over x squared plus x
May cause inaccuracy.
What kind of a value do you give?
A very, you.
Now we got a super big number, right? Because it says times e to the 10th. So would that be the answer?
Since they're not equal, you can.
No, right? What happens at 0? What do we have?
Vertical asymptote.
A vertical asymptote, right? So that means the graph is gonna get infinitely close to it, but never touch it. So that means if I'm getting infinitely close to it but never touching it, I'm able to find a little bit of area bounded between that curve and that asymptote, right? But will I ever be able to find that total amount? No, because it's going to what? To infinity, right? So I'm never gonna calculate all of it. And then I'm gonna come to the bottom and try to calculate all of that, right? So that's why I'm getting a super big number, okay, because it's putting all that in. If we worked it out by hand, we would have gotten 5/3, okay, which is wrong as well, right? So be very careful, always check for continuity and differentiability before you jump into them, okay? And be careful with your calculator, because it could throw out an answer just like that one just did, okay? Check out this guy right here. Is this one continuous? No, where is it not continuous?
Or take the